11.3 is our next section. It's called Systems of Nonlinear Equations. And inequalities two variables. Long name there. All right, so systems of equations, still working with systems. However, now we're switching over to nonlinear, which means one or both of my equations will not produce a line when I graph them. And inequality, if you remember, are greater than, less than, greater than, equal to, less than, equal to, these types of things. All right, so let's just talk about graphically what this means when we're talking about systems of nonlinear equations. Let's give an example. So let's just say we had an equation. I'm not even going to give you what it is. I'll just graph it for you. If we were in class, I'd ask you, what is this? Hopefully someone would remember from college algebra that that's a parabola. It's a quadratic equation, which if you remember, that means it has some y equals ax squared plus bx plus c format. And then if, let's say I had another equation, I'll graph that one in blue. This guy I will make linear. That's a linear equation, so that's a y equals mx plus b form. All right, but because the quadratic is not linear, that's why this is going to be in this section. Notice that if I were to ask you, where do these two lines intersect? Your answer should be no intersection, which means we have no solutions to this system of equations. All right, well, let's look at an example where we might have one. I'm going to use the same type of graph, a quadratic and a linear. So let's say I'll just give myself the very same looking parabola. And in this case, let's just say I had a line that touched, trying to make it touch very precisely at one single finite point. So we have a tangent line, essentially. Tangent line. So that would be a situation where we had one solution. And then you can imagine, let's do the very same equation, or the very same graphs. We'll do that same parabola that opens up. And we'll use the same linear equation, except for it's going to go through it like so, making it more of a secant line. And notice that I have two intersections. It crosses twice. So we can actually have two solutions when we are working with nonlinear systems of equations. All right, so let's look at an example. Let's see one where we're actually going to solve. All right, so my first one will be x minus y equals -1. My second will be y equals x squared plus 1. All right, let's look what it would be like to solve this guy. So in this section, I'm going to use substitution. So when I use substitution, I'm going to always plug my lower degreed equation into the higher degree. So this guy is a lower degree. He's a first degree. He's a linear. So I'm going to plug into my quadratic. I always try to do it this way. So in this case, I'm going to use substitution. I'll say using substitution. So let's solve him. It doesn't matter which one I'm going to solve him for. I'm going to solve him for, how about y? If I solve him for y, he would be x plus 1. This one here, solving for y. So in that case, I will take him and I will plug in x plus 1 into the y side. So I've got, instead of y, I'm going to say x plus 1 is equal to x squared plus 1. All right, let's get all of our variables on one side of the equation. X squared minus x. Actually, that's all. The ones cancel out, don't they? So if I want to solve this, I'm looking for solutions. This goes back to college algebra where we had to solve different types of polynomials. If I want to solve, I'm going to factor out an x, and that will leave me with x minus 1 is equal to 0. And then I would set each one equal to 0. So x would be 0 and x would be 1. So again, notice that we can have two solutions based on this scenario right here. We can have two solutions. So now to find the y's, I'm going to plug them back in. I'll plug them into, I'll plug them in the first equation, I guess. So actually, you know what? I'll plug in this one right here. Y is equal to x plus 1. If x is 0, that means that y will be 1. And then if y is 1, I'm sorry, if x is 1, plugging in right here, oops, that means that y will be 2. So my two solutions in this case are 0, 1 and 1, 2. So if I were to graph these two guys on, actually, you could graph him real quick. So if I wanted to graph the quadratic, he's moved up by 1. That's really not a very pretty looking quadratic, is it? Try and make him a little nicer, a little more symmetric. All right, and then I know that my linear is going to cross at 0, 1. So 0, 1 will be here. And then 1, 2 will be here. And we'll say it's right here. So that will be my linear. So that's where my two... All right, we also have inequalities in this section. So nonlinear inequalities, in fact. So let's look at an example. Let's say we have y is greater than x squared minus 4. So first of all, we're going to have to graph this guy. I'm actually going to set the same inequality up 4 different ways and graph him 4 different times to really give you an idea of what's going on in this section. All right, so if I have y is greater than x squared minus 4. So the way I'm going to graph this guy, first of all, I'm going to pretend like he is y is equal. Let's look at it. Let's pretend as though it was y is equal to x squared minus 4, just to get the general format. Hopefully you recognize that this is a quadratic, which makes a parabola. Hopefully you remember that this minus 4 right here means a vertical shift down. So if I were to graph him, we would go down 4. And let's find out where he crosses the x-axis. That, remember, to find where he crosses the x-axis, that means that y would be 0. So if I solve 0 equals x squared minus 4, that means x squared equals 4, which means x would be plus or minus 2. Hopefully you remember all of this from college algebra. So I would plot those 2 points. These are my intercepts. All right, so this equation looks, the y equals x squared minus 4 looks like this. All right, so what is y? So that would be this graph here. What does this one look like now? All right, so we have 2 things we need to look at. First, we need to look at the inequality. If it is greater than, if you remember from college algebra, we said that was that would be an open circle when we were plotting it on the number line. So in this case, what we're going to do is we're going to call it dotted. It can't actually equal. It cannot exist on. Oh, you know what I can't do is I'm going to have to do another color, because if I use my eraser to try to erase and make it a dotted line, it's going to erase the entire thing. So instead of, I'm going to use black. I'll make it dotted on top. So it's dotted because y can never actually be on the line. It has to be greater than. So then how do I figure out? This would be a shading problem. oops, I did not mean to make that look like a greater than or equal to. This is a shading problem. So what I'm going to do is I'm going to take a test point inside my parabola. I really don't need to take a test point outside it, because if my inside is right, that means I should know the outside already. So I'm going to test 0, 0. That's my easiest one to test. So if I plug 0, 0 into my inequality, I have 0 is greater than 0 squared minus 4. 0 is greater than negative 4. Ask yourself, is this true? And you would say, yes, indeed. 0 is greater than negative 4. That would mean that I would I would shade inside my parabola. You could technically test a point outside of the parabola as well, but you should get a false statement, and I'll show you a false statement in a minute. So let's look at, again, I said we're going to look at the same one in 3 different scenarios. Actually, if I had greater than or equal to x squared minus 4, it is exactly the same. The only difference is because of this equal, that makes it a solid line. So if I have an equal sign, I'm going to make it solid, just like it was an equals, y equals x squared minus 4. And then the shading works the same. I picked the point inside. It was still true. If I picked 0, is 0 greater than or equal to negative 4? Yes, it's still true. So I still would shade inside. All right, let's look at a false scenario. Y is less than x squared minus 4. Keeping with the same graph just to make it easy. So if I was going to plot this guy, he would be down 1, 2, 3, 4. He crosses at 2 and negative 2. All right, so because he's less than, there's no equals, he's going to be a dotted line. Dotted line for my parabola. All right, then again, I'm going to take a test point. 0, 0. I always go for the easiest ones, the lowest hanging fruit. 0, 0 is the easiest. 0 is less than 0 squared minus 4. 0 is less than negative 4. Is that true? That is not true. That is false. That means this is not within the shaded area. Outside, everything outside of my parabola would be shaded. Again, you could take a test point outside, but honestly, there's no need, as long as you do your math correctly from the beginning. All right, the only other scenario we would have is if y is less than or equal to x squared minus 4. And just like with the greater than or equal to, it means it's going to be a solid line instead of a dotted. But the test point is exactly the same.